Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to calculate the arc length, radius, and the angle of a sector. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one. So we need to calculate the length of the arc of its sector. So first one, part A. So it is a semicircle, half of circle if you like. So we know that circumference of a circle is pi d or 2 pi r. So part A is half of circle. So this is the diameter. And we need to calculate this arc length here. Okay, so the circumference of a circle. So half of it. Okay, keep that in mind. And we know that the rule is circumference, but this time is the arc length. So we just write L we do. L, the arc length of this is circumference of a circle is 2 pi r or pi d. In this case, I use pi d. It's easier, that's all. So pi d. And this means that it will give me the whole circle, okay, circumference of a whole circle. So we only need half of it. We times by a half. Or we divide by 2 if you wish. So now the diameter here is 6 centimeters. So we just replace with that. So that is pi times 6 because the diameter D is 6 centimeters. And we times a half. That will give me, so just go shift pi times 6 times a half or 0.5. So there you go. And we need to round up to 1 decimal place. So 9.4. So the answer is 9.4 centimeters. So there you go. Part B. So we need to work out the length of this arc here. And it's a part of a circle. So we know that circumference of a circle is 2 pi r because the radius of this is 5. So we just use 2 pi r. So the arc length, let's start with circumference of a circle, is 2 pi r. And that will give us the whole circle. And we only need one fraction of it, that is 30 degrees out of 360 degrees, because in a whole circle there are 360 degrees. So we only need 30 degrees out of 360. So 30 divided by 360, that will do. And we know that the radius is 5 centimeters. So r is 5. So now I just put that together. So 2 pi times 5 times 30 over 360. So that is equal to, so I just go 2 shift pi times 5 times 30 over 360. So there you go. Correct to 1 decimal place. That means one number after decimal point, 2.6. Because the number after 6 is 1, less than 5. So we keep it as it is. The answer is 2.6. So 2.6 and the unit is centimeters. So there you go. Part C. So first of all, we know that the circumference, let me just write L first, and the rule for circumference is 2 pi r. So that will give us the whole circle, okay, circumference of the whole circle. Now it's 90 degrees because this symbol means 90 degrees. So 90 degrees over 360. And we know that this is a quarter of a circle. So easier or faster, it will just time by a quarter. Of course, you can just time by 90 degrees out of 360 degrees. And it gives the same answer. Keep that in mind and just write in the simplest form. That's all. And the radius in this case here is 12.4. So that will give me equal to 2 pi times 12.4 and we times by a quarter. So that will give me, so 2 shift pi times 12.4 and we times 1 over 4. Or you can type divided by 4. Okay, nothing wrong with that. 19.4, 7 and so on. So correct to 1 decimal place. So one number after decimal point. So 19.4, but because the number after 4 is 7. So we remember that from 5 onward, we need to add 1. So 1 plus 4 is 5. So the answer is 19.5. So 19.5. And do not forget the units, centimeters. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through it with you. Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So part D. So we know that circumference of a circle is 2 pi r and we only need one part of the circle. So let's just write L. So L is the length, okay, the arc length if you wish. L is equal to 2 pi r, that is the circumference of a circle, and we only need to work out this part, one part of it, okay? So that is 35 degrees out of 360 degrees. So that's it. And we know that the radius is here, and that is 8 centimeters. So R is equal to 8. So that means, which is equal to 2 pi times 8 times 35 degrees out of 360 degrees. So that will give me, so just go 2 shift pi times 8 times 35 over 360 degrees. So there you go, 4.886 and so on. So the answer is 4.9 centimeters, correct to one decimal place. So 4.9 centimeters. So there you go. Part E. So we know that circumference of a circle is 2 pi r, and we only need to find part of the circle. So that is 220 degrees. So let me just write out the rule first. So you know that L is 2 pi r and times by 220 degrees out of 360. Or just write 220 out of 360 we do. We just need to work out the fraction of it. Yeah. And now the radius is 21 centimeters. That is the radius. So 21 centimeters. So that is R is equal to 21. So we just substitute that in. So 2 pi times 21 times 220 out of 360. That will give me, so I just go 2 pi times 21 and we times by times 220 out of 360. So there you go, 80.63. So the answer is 80.6 because the number after 6 is 3, less than 5. So therefore, we just write 80.6. So 80.6 centimeters. So there you go. I hope you got it correct. Now, part F. So first of all, this is the arc length that we are after. So that is 3/4 of a circle, if you like. Otherwise, we know that this symbol means 90 degrees here. But we need to work out this part. Okay, so that is 270 degrees. So therefore, the circumference of a circle is 2 pi r. So we just need to times by 270 out of 360. Or just times by 3/4 will do, because it is 3/4 of the circle. So now we just write L is equal to 2 pi r. That is the circumference of a circle. So we just need to work out 3/4 of the circle. So it's times by 3/4. Or 270 out of 360. So that will give me, and we know the radius is 4.5 centimeters here. So r is 4.5. So 2 pi times 4.5 times 3/4. Okay, or you can just write 270 over 360. Doesn't really matter. So that will give me, so just go 2 pi times 4.5 times 3/4. So there you go, 21.105 and so on. Remember, we need to round off to 1 decimal place, so 21.2. So 21.2 centimeters. So there you go, and I hope you got it correct. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through them with you. So first one is, we know that L is 2 pi r, and we times by 25 out of 360 degrees. And the radius 12.7. So that is equal to 2 pi times 12.7 times 25 over 360. That will give me, so 2 pi times 12.7 times 25 degrees out of 360 degree. So there you go, 5.54. So it's 5.5, correct to 1 decimal place, because the number after 5 is 4, so less than 5. So therefore 5.5. So 5.5 centimeters. So there you go. H. So we need to work out the arc length of this. So this is major arc, if you like. And we know that this is 80 degrees. So remember, in a whole circle is 360 degrees. And we need to work out this angle here, not this, okay? Not this 80 degrees. So therefore 360 minus 80 degrees. So 360 minus 60 is 300. We need to minus another 20. So therefore 280. So 280 degrees is inside. So therefore we just go arc length is equal to 2 pi r, and we times by 280 degrees out of 360 degrees. So the radius is 17.6 centimeters. So r is 17.6. So which is 2 pi times the radius 17.6, we times by 280 over 360. That is equal to, so just go 2 pi times 17.6 times 280 out of 360. So there you go, 86.009 and so on. So the answer is 86.0. So 86.0 centimeters. Part I. Again, we need to work out the arc length of this. And we need to work out this angle, of course. So therefore, you remember in a whole circle is 360. So therefore 360 minus 150. So 300 minus 150 give me 150, and we add 60 on top, 210. Otherwise, you just put on the calculator, 360 minus 150 should give me 210 degrees. So that's the angle. So therefore, the arc length is equal to 2 pi r, and then the r is 31.5. Okay, and don't forget, we time by a fraction of it because it's not the whole circle. We only work out the 210 out of 360. Out of 360 degrees. So that will give me, so I just go 2 pi times the radius, 31.5, we times 210 over 360. So I just go 2 pi times 31.5 times 210 out of 360. So there you go, 115.45. So 115.5 centimeters. So 115.5 centimeters. So there you go. I hope you got all of them correct. Question number 2. So we know the arc length is 21 centimeters, and we know the angle of the sector is 32 degrees, but we need to work out the radius of this sector. So remember, we just start with the rule. So we know that the circumference of circle is 2 pi r, but we just need to work out this arc length here. So L, and the fractions is times by 32 degrees out of 360 degrees. So there you go. So we just need to substitute the value in. We know the arc length is 21. Okay, so that is 21 centimeters is equal to pi, and we're not sure what the radius is, just times by r times 32 out of 360 degrees. And we know that we just use calculator to work this out. 2 pi times 32 out of 360. Okay, so let me just put on a calculator first. So I just go 2 pi times 32 over 360, or divide by 360. So there you go. So that is 0.55 and so on. Let me just write 0.56 we do, because I'm going to use the whole number on the calculator later on. So it doesn't matter how many decimal places are right. Okay, so 0.56 first. Okay, so that means 21 is equal to 0.56 times the radius. So that means times r. So that is r. Then to solve for r, so I just need to divide this by 0.56 divided by 0.56. So this cancel out. Just remember that. So therefore, r is equal to, so what I do, I just go 21, we divide by, instead of divide by 0.56, I just press the answer button. So that is 0.55 and so on. Remember that, the whole numbers. So now we just put on a calculator by just divided by answer. So that will give me more accurate. So that is 37.60 and so on. So 37.6. So the answer is 37.6 centimeters here. But we already have the centimeters. We just need to work out the r, value of r. So 37.6. So I hope you understand. Now, please pause the video and try these two yourself. Hi there, I'm back. How did you go? Let me go through it with you. So first of all, we know that this is a quarter of a circle, correct? Because this is 90 degrees. So we can time by 90 over 360 or times a quarter, okay? However you want to do it, doesn't really matter. So we know that we have the arc length here is 10. So we know that the rule is, so that is 2 pi r, and we times by the angle that is 90 degrees out of 360, or we just type a quarter. That would do. And the arc length is 10. So let me just write this down. So that is 10 equal 2 pi times the radius. That's what we need to after. You times by a quarter. So we just put this on a calculator. 2 pi times a quarter. First, 10 equal, and we just need to solve for it by divide this by, and because it already have centimeters here, we just write the value of r. Now, next one, the radius is here, and the angle is 145, and given the arc length. So we know that arc length, L, is 2 pi r, and we times by 145 out of 360 degrees. And the radius is we need to after, and the arc length in this case is 15.8. So we just substitute the value in. So that is 15.8 is 2 pi times the radius, you times 145 over 360. So the answer is, so we just go 2 pi times this first. So just go 2 pi times 145 divided by 360. So there you go, 2.53 for now. So the answer is 15.8 is 2.53 and times the radius. So that is r. So now we just divide by 2.53 on both sides. So I just go 15.8 divided by the answer. So there you go, 6.24 and so on. So 6.2, okay? So r, therefore, r is 6.2. That's it. That's a value of r. So there you go. And I hope you got it correct. Question number 3. So given the radius and the arc length, we need to work out the angle theta, correct to 1 decimal place. So first of all, we know that the arc length, L, is 2 pi r, and we just need to work out one fraction of it. So the fraction is theta out of 360 degrees. So there you go. So what I do now is I just substitute the value in. L is the arc length is 7, whereas the radius is 3 centimeters. So I just put that in here first. So 7 is 2 pi times 3 times the angle theta out of 360 degrees. So what I do, I just use the calculator, work this out first. So 2 pi times 3, then we divide it by 360. Okay, so let me just write 7 down here first, equal. So I just go 2 pi times 3, we divide by 360 degrees. So there you go. Let me just write down 0.05 first, okay? So 0.05 times angle theta. Then to solve for this, I just divide this by 0.05 divided by 7 by 0.05. That cancel out. So I just put on the calculator. So again, instead of type 7 divided by 0.05, I just go 7 divided by the answer. So that will give me accurate, okay? So 1 decimal place, 133.7 degrees, because the number after 6 is 9, so we add 1 to 6, so 7. 133.7. So angle theta is 133.7 degrees. Okay, don't forget the symbol degrees. Please pause the video and try this to yourself. Hi there, I'm back. How did you go? Let me go through them with you. So we know that the arc length is L is 2 pi r, and we need to times the angle theta out of 360 degrees. And we know that the arc length is 18 and the radius here is 8. So we need to work out the angle theta in degrees correct to 1 decimal place. So 18 equal 2 pi times the radius is 8 and we times by theta out of 360. And we just put on a calculator 2 pi times 8, then we divide by 360. So I just go 2 pi divided by 360. So there you go, 0.14 will do. So 18 is equal to 0.14 times the angle theta. You can write time theta or 0.14 theta. Still correct, okay? Remember your algebra. So now what we do, we solve for angle theta. So I divide this by 0.14. We divide this by 0.14. So that cancel out. So therefore, theta is 18 divided by the answer. So there you go, 128.9. So 128.9 degrees. So there you go. So we know that L is 2 pi r times theta out of 360 degrees. And the radius is 17 and L is 15. So 15 is L, 2 pi times the radius is 17. This 17 here is a radius. And we time by angle theta out of 360 degrees. And what I do, I just put on a calculator. It's 2 pi times 17 and we divide by 360 degrees. So I just go 2 pi times 17 divided by 360. So 0.296. So let me just write 0.30, or you can just write 0.29. Doesn't matter because we're not going to use those numbers. We're going to use the answer, right? Or you can just write 0.30. 15 equals 0.30 times the angle theta. Just put time in between. So it's easier to read, that's all. So now I just get rid of this by divided by 0.30 divided by 0.30. So that cancel out. So that is theta equal. So just go 15 divided by the answer. Okay, don't forget. So 50.6 degrees. So 50.6 degrees. That is the angle theta. So there you go. I hope you got it correct. Please stop the video and do this one yourself. Hi there, I'm back. Let me go through it with you. So first of all, do not forget the arc length is this length here. And therefore, we need to work out this angle first. Let's say make it x before we can find angle theta. So to work out angle theta, we just need to work out x and then 360 minus x. So give us the angle theta. So keep that in mind. So now we know that L is 2 pi r and times a fraction of it. So which is times by x over 360 degrees. So please keep that in mind, okay? Or just let me just write 360 will do. We just need to work out mathematically, that's all. And the arc length is 13. So 13 equal 2 pi times 9.5. That is the radius. And we times x out of 360 degrees. And we just need to use calculator. 2 pi times 9.5. Then we divide it by 36. So I just go 2 pi times 9.5. And then we divide it by 360. So there you go. 0.17 will do. So let me just write this down. So 13 is equal to 0.17 times x. So that is 0.17x. And we just need to solve for x for now. So now we just divide this by 0.17 divided by 0.17. Let me just draw a line here. So that is x is equal to, so just go 13. We divide by the answer. So there you go, 78.4 degrees. Okay, so x is equal to 78.4 degrees. Now to work out the angle theta, so angle theta is 360. Theta is 360 degrees, and we just minus 78.4 degrees. That will give me, so I just put on a calculator. So just go 360, which is minus the last answer. So there you go, 281.6 degrees. So 281.6 degrees. So there you go. Thank you so much for watching. Bye.